exquisite and webinar on Veraqor's predictive maintenance solutions. So we do this every quarter, a few times, when we bring you the most latest and conductive operations and the solutions that could be incorporated right into your firm and your industry, where you could be taking your firm where it is right now and take it to the growth side, and always have it a scalable solution so you could be moving into the right direction for the coming next 5 years, because we know that technology keeps changing at a very fast pace. Today, the topic is going to be Veracor's predictive maintenance solution and how it will actually be taking you to the next step. Now, let's move directly into it. I believe at this stage, and if you're an industry leader yourself, you would very much know what predictive maintenance would mean. But what's at the stake? Why would we bring you this very important solution or a task that is needed to be done across all the industries, for majorly for the manufacturing units and the people who are actually doing a lot of R&D with machines? We have $50 billion of annual cost of unplanned downtime. Now, the source is none other than Deloitte itself. The reactive maintenance is specifically raising in costly surprises. And after all, the preventive maintenance, which a lot of people are a fan of, is causing inefficiencies. Now, what exactly does that mean? So basically, there are 5 steps, or like 5 maturity steps, where the companies or the firms usually are trying to be in the maintenance realm. The first one usually comes at the reactive one. At this level, organizations are usually waiting for the equipment to fail before acting. And once they do, they start going in and start replacing everything. But it's costly because it's unplanned, plus it's risky as well. The safety index for these companies is very low, and specifically are getting a little bit of fines from the government level as well. Now, especially in asset-intensive industries. The second one we all know is going to be the preventive one, where the maintenance is scheduled at regular intervals, and whether the asset needs it or not, you still got to be there and make the changes done. What this does is this actually reduces some risk, but it can actually lead to unnecessary downtime and higher cost. Why the higher cost, you must be thinking. The reason is that you're not using your equipment to its full life, and you have replaced it before it can actually get consumed all the way to the maximum. The third one is the condition base. Now the sensors start to come into play. This is very important, and it's a major step where the things are actually getting towards the automation, where the maintenance decisions are actually based on the vibrations and the temperatures of the whole machinery that the system has been set up in. This is a big step forward, aligning actions specifically with actual equipment health. The fourth one, where we actually want to be, is the predictive one. Now we start to see the analytics and the machine learning applied to the historical and the live data. Now, this way, we can actually forecast the failures that are coming before they even happen, allowing them to be done in real time and justify the interventions that are being done by the team as well. This is what we're going to be helping you with the most, getting you to the right decision making. Afterwards, what happens is the prescriptive one. This is the final stage where the AI is built in, is so strong that it's actually giving you recommendation as to how to make your equipment last even longer. This is the most advanced level. It not only predicts the failure, but also recommends the automation that you could be doing in the future. It's also autonomous decision making and tight integration with the rest of your equipment and your ERPs and the CRMs would actually bring you the decision making capability that not even ChatGPT would be able to do it at the moment. So with that said, the movement that we're trying to bring in, let's look at what predictive maintenance looks like, because I believe that all the industry leaders are very well aware of it. But just to recap real quick, it is something that we're trying to do to boost the equipment reliability and help the organization stay ahead of the unexpected issues. Predictive and prescriptive, whenever we think about that, these are two of the realms where the things are supposed to be done by the program that we have put in instead of the people doing the intervention themselves, resulting in reduced downtime and inspection cost, enhanced safety standards, increase in the energy and efficiency, and preventing the unexpected breakdown. And obviously, when you optimize the scheduling, you might even be needing lesser of the maintenance folks that are on the ground trying to figure out what to do next. Let's see what the value proposition is, because at the end of the day, everything is a deal. We're looking for the profit and the loss. It's specifically my question, if I was in the field trying to figure out how to keep my maintenance on the top, I would always ask the question, what is the cost of getting the solution done, and what is the cost that I'm incurring if I don't have the solution done. So the value proposition that this specific solution offers is reduced downtime by up to 30%. Now, this is the number that we have gotten by research through Gartner and Deloitte, and the big ones that are out there trying to get us the numbers from most of their customers on the ground. The extension of the asset life is merely between 20 to 40%. And this is not less, this is a lot, because if you're just talking about a single piece, think about how it would add up when a lot of pieces are involved in there. Then we can cut the maintenance cost by 20 to 25% as well. This specifically is happening because now you have the information available on your screen even before you send someone to look for that information. One of the real world impact story that we have come across that very much would interest you is the United Tractors. They've been picked up by the Microsoft as a unicorn as well in the specific realm of predictive maintenance, where they were operating across 100 plus sites, struggling with high downtime and manual maintenance. But by moving from SAP HANA to Microsoft Azure, they embraced AI-driven predictive maintenance and real-time analytics. Now, this cloud-first strategy cut the unplanned downtime by around 30%, boosted the uptime by 25%, and enabled 30x faster application deployment. No extra capital needed right there. Given that you actually move to the predictive maintenance, what it offers is the seamless collaboration, the actionable insights, and the agile operations that come along with it. Let's dive a little deeper into it. But before that, now that we have put in the stakes that are there that you might be losing collectively billions of dollars, you're losing time, you're losing money, and there is some operations that are being done that could just be automated. We have to also think about why are we not moving to that solution already? Because this solution is not something new. Predictive maintenance has existed for nearly more than a decade already now. It's only improving as the time passes. Why are the firms or the industries or the companies not able to get into it? What are the challenges? Well, we have been in this field for far too long. We have talked to a lot of people, a lot of customers, and what we have come to is specifically the 5 challenges. These are the 4 ones that you see on your screen right now, and the 5th one, the bigger one, is going to come in the next slide. First and foremost, there's internal resistance. People or the folks or the board members are not actually invested into knowing what predictive maintenance would help them. Or sometimes they don't even have the resource to calculate what would be the savings that they would be doing if they have the solution in place, resulting in internal resistance. Most of the time, it's also that the employees or the people who are actually working in the maintenance department have a little bit of fear that this is going to be something that replaces us. I'm going to be very clear with you. This is not what predictive maintenance does. It's only there to assist you with the operations that are ongoing at the moment and make your estimations or the assumptions even far better and more accurate. The next one is the lack of envisioning the long-term benefits. How strictly is that going to come in? There are only 2 ways to do that. Either you have internal research done and have a plan and have a strategy in place where you're envisioning the long-term benefits of what predictive maintenance is going to be doing, but that mostly gets dissolved in a day-to-day task because there are so many things going on that the R&D is not properly done or not properly furnished. That's where Veraqor comes in. We give you briefings about the predictive maintenance. We tell you specifically how much you could be saving, specifically how much capital or cost you would require in order to get to the stage that we want you to be, and what the pathway is going to be. The third one is expecting the tech partner to over-deliver on industrial knowledge. We have had this case in our own experience as well, where we have been talking to a client and they were very interested in predictive maintenance and how things are going to be done. But as we move forward, they started testing us on specifically what the knowledge about the industry is with you folks. I just want to make it very clear that all the software companies that are actually offering tech solutions, they are the masters of it. They know how exactly to do it, how to impart that knowledge, and how to bring it to fruition as well. Asking them specifically how a specific sensor would be working, or how the rig operations are working, or how the manufacturing floor is being conducted is not their job. Their job is to get you the right solution and integrate it. Where the industrial knowledge comes in is from the SMEs that are actually sitting in your industry, in your firm, in your own offices, where we have workshops with them, we collaborate with them, we understand their pain points, we understand the processes that they have to go through day in, day out, and we make notes of it. And as we start the development of the tech solution that we are putting in, we closely calibrated with the KPIs or the pain points that you have on the business side from the SMEs that we have collected over the time in the workshops. This actually bridges the gap between the industrial knowledge and the knowledge of the solution. So it's a border. We get the information of the industry from you, and we give you the information for the tech solution that we are about to put in. The fourth one is the upfront cost of implementation and deployment of solution. This is also something that scares the people or the industry leaders, specifically how we're going to be making the ROI on the solution that we're trying to implement. And the upfront cost of implementation could be a bit scary, even if there are no sensors installed on the machinery that you're using already, or you have a legacy system where a digital transformation is supposed to be needed. But worry not, that's what the POCs are actually for. What we do is we start with a proof of concept, which is very minimal in the cost and the time that it requires in order to make it running. So for example, if you're in the oil business, we pick up and you have multiple of the rigs that are working, we pick up a single section from a single rig and start POC on that. We actually make it equipped with the sensors if it's not already. We start with the predictive maintenance solution. We start with the fabric implementation. That is something that we recommend all the time for any kind of analytical solutions that are coming in. But since Veracor is agnostic, technologically agnostic, it could be even AWS or the GCP that you're working with. But in our experience, working with Microsoft and its technology has given us some arsenal that is not available anywhere else. And since everybody's already using the Outlook, the Teams, the Word, the Excel, it's so seamlessly embedded into the ecosystem that you're already in that the solution just looks like that it was always there. So the upfront cost of implementation and deployment of solution can always be negotiated, brought down. There are discounts available. And to begin with, it's not that even big of a deal. What it would actually come down to is just having a couple of hours of briefing session in which we actually let you know that the upfront cost of implementation is specific to your solution is not even what you fathom. The last one and the big one that we actually see, the challenge that is coming straight up from internally, is that we already have predictive maintenance offered from vendor we buy the machines from. This is a very valid thing to say, and it actually makes sense that a lot of machinery that is being bought has upgrades done, which has the IoT sensor involved. The machines have the sensors for vibration, the temperature. It's also telling us specifically what kind of warranty or the guarantee is on the parts, and we try to actually manage ourselves or calibrate our approach according to that. But then I have a few questions to the people who are interested in that solution. That is your current system that you have gotten from buying the machinery siloed to individual machines or plants? Mostly the answer is yes. Can you actually aggregate the predictive insights across assets, sites, and business units? Mostly the answer is no, because it's just the machine that you're getting the information from, and it's like a black box or a very legacy system that people are using in order to know if the system is working the right way or not. The third one is, do you have automated escalations, alerts, and integrations with planning or supply chain systems? What this means is that definitely the machine is not working all by itself. It's working in a system. There is a supply chain system that is going on along with that. There is an operations going on that. Obviously, it's getting impacted by something that is coming before that. It's also impacting something downstream as well. Do we have the escalation and alerts and integration across the system usage that is happening? And why is that even important to have a integration across the system? Is because everything is dependable on the other thing. Nothing is working like a solo island. So in order to have the decision-making capability that the decision maker or the leaders of the industries are looking for, they have to have a bird-eye picture. And along with that, it's supposed to be given to them in a brevity style where things are summarized and given to them in a proper dashboards so that they could be making the decisions that are needed in the real time. The fourth one is if the model is the model improving over time as it learns from the new failure patterns. This is where the predictive maintenance and the prescriptive maintenance, the step afterwards, it starts from. Usually the answer is no to that, because all they're doing is they're actually just the eyes or the senses of the maintenance person itself. So instead of sitting or going all the way to the field and trying to see if something is working wrong or right, they could just be sitting in a remote control room, and they would just be knowing if the vibrations or the temperatures are going on right or not. And that's where they start making the decisions based on. But this is not enough, because if you are collecting the information or the data in today's age in 2025 with the advent of AI and spreading all across the industries, this is not enough. We have to make smart solutions where the solution itself is learning from the readings that it's doing. And we are the ones, the Veracor is very much adamant to put your data to work, because data is money in real world in today's era. And we have to use it to figure out the patterns. What are the success patterns? What are the failure patterns? And going forward, these patterns are supposed to be giving you the optimal results. Talking about the challenge that lots of time we hear from the customers that we already have the predictive maintenance software from vendor we buy the machines from. And discussing the point, can we simulate different maintenance strategies or asset failure scenarios? Now, this is specifically would come down to the place where we know exactly what we're simulating, trying to figure out if there are any kind of new integrations, if there are any kind of new things that are coming in, and we try to bring it into the new realm, giving the opportunity and the power to actually know the cost of operations, the cost of failures, and the downtime and its impact before it even happens. And this is what we're talking about when we say productivity or the efficiency is going on to the pinnacle of how it could be. And something that we have seen is that most off-the-shelf PDM tools are black boxes, right? They're limited in scope and they lack innovation for the long-term learning. Think about it in a way that if you have Oracle, you have SAP, how difficult is it to actually move or integrate it with something that is not Oracle or SAP? Like, for example, in Fabric, if you're trying to include everything in the Fabric and Oracle, trying to make it work together, there are APIs involved, but there's a lot of coding involved as well. You have to create some bridges. Those bridges are getting individually even difficult to achieve if you have just the legacy system that is sitting in, which is mostly what we get when we have out of the shelf off-the-shelf PDM tools that are available, because they do not have the integration or the scalability that you would want for the next 5 to 10 years. Now, something that I'm always tell my customers that it's coexistence, not replacement, because we have seen the internal side as well. We are not here to rip and replace your current solution that you're here to actually enhance it and integrate with what you already have into the future ready platform. Because as we know, there's a Moore's law right in front of us working at the speed of light. Things are moving into the direction of innovation and scalability at a pace that we can't even keep up with. So making long-term plans, specifically depending on the technological solution, is not the fashion anymore. We have to stay with the time and have a solution in place that is scalable all by itself, and the recommendations are created in real time too. Let's see some of the trends that we have seen. I'm picking up oil and gas industry just as an example to tell you a little bit of the trends that are going into the predictive maintenance. First of the trends that is very interesting to me is that 74% of oil and gas companies use some form of predictive maintenance to reduce unplanned downtime. Now, what does that tell us? That actually tells us that if we are not amongst those 74%, we're actually losing out. And it might not look like a big thing as of now, but in a few years, this will become very evident that we're not able to get to the production levels that these companies that have predictive maintenance to reduce their unplanned downtime are employing. The second one is that this market in the oil and gas industry is expected to grow at a CAGR of 25.7% from 2021 to 2028. This is a big number. It's not supposed to be meddled. The third one is that predictive maintenance can reduce the unplanned downtime by up to 50%, ensuring better outcomes for enterprises. This is something that I'm repeating for the fourth time now, because this is a huge thing when we talk to the industry leaders, the unplanned downtime is not just a loss of production hours, it's also the opportunity cost of creating something much better. The dependency or relying on a solution that is working all the time, the peace of mind is something else. And obviously, the stakeholders are not looking just for things to be working, they want working at the most optimal level. And this is what the predictive maintenance brings us a step closer to. The fourth one is that companies that use the predictive maintenance experience a 27% increase in equipment availability and a 30% reduction in maintenance costs. Again, the cost and the availability, those are the two things that we're going to be most focused on. And those are the business values that we're deriving from the solution. If there's any other solution that could be giving us better numbers or increasing our KPIs even more, we are more than happy to actually move towards that as well. But as clear as there's daytime, we want to know what it's going to be to bring us to the next step. And it's pretty clear to us that predictive maintenance is something that is very straightforward and very straightforward to actually implant in your own operations in order to move to the next step too. What does predictive maintenance actually look like? So now that we have established that there is a need for it, and we're definitely going to be the ones who are supposed to be on the other side where the predictive maintenance is working, let's see what a solution overview looks like. So suppose you have an assembly line equipment on the left shown right here. There are two kind of issues. There's a known pattern of destruction or pattern of loss of quality in the product itself once it's getting used, and there's going to be could be unknown or the unpredictable kind of issues that you might not have seen before in your own experience. Both the solutions, both the issues can be catered really well with the solution as well. The known issues where the equipment usage pattern is recognizable or identifiable goes straight up to the predictive maintenance model that we create for you. The equipment usage pattern and identification and classification is embedded right into the system, where it's trying to learn from the historical baggage, the data that you already have collected over the year, and we're putting it right on the money. We're trying to make your data work on there. The model is going to be recognizing what the patterns could be, depending on the time constraint, depending on the physical location, the vibrations or the temperature or the country that you have put it in, the humidity level, or even the usage as to how much usage you're getting out of it. And depending on that, we should be able to actually get the information out of it as to when the next maintenance is supposed to be done or when a part could actually be deceiving you to bring your production down. The second zone, which falls under the radar of anomaly detection. Now, anomaly detection is where the anomalous equipment usage pattern identification is done in a fashion of relying on the most highly sophisticated confidence rate of above 90% rate, 90% in most of the models. Now, the anomaly detection, what it does is these are some of the issues that are not very viable or haven't been visible in the past, but sometimes when things start getting brought in, it could be brought up right in real time and shown up in the data visualization and analytics platform right on your screen. I'm also going to be showing you in a little while how it would look like and what the solution would be at the end when you implement the whole thing. We have a customer use case from one of our customers in oil and gas equipment management company where we have actually done the predictive maintenance. This is one of the many that have been implemented from our side. And it's basically for Chevron, one of our biggest clients out there from the North America. And we are dealing with its Tengiz. It's one of these contemporaries in Kazakhstan as well. This was a solution that we have implemented in Kazakhstan where we integrated their sensors, their IoT, their maintenance sheets, the regulations, and the day-to-day manual processes. We automated those and brought all of the and equipment building and its specs into a specific dashboard. And we did it in Azure Synapse, but since then we have the availability of Microsoft Fabric as well. This is what we're going to be moving forward. And as you're speaking right now, Microsoft Fabric is being implemented in Chevron by our software developers as well right now. Now, this extraction and loading initial data and cleansing it and bringing it into the whole dashboard and the reports, which could be giving you the decision-making power, is a wholesome solution. It's not just about predictive maintenance. Predictive maintenance at the end becomes just a part of a giant solution that you're putting in. This analytical solution can be scalable to any of the workloads that you're trying to do. You could be embedding it in your ERP, in your CRM, in your regular definitions of the operations. It could be anything. It could be supply chain. It could be building the intelligent workloads. It could be even checking out the headcounts. It could be seeing what the workers are doing in the real time. Once we have the platform embedded and the landing zone has been created, these solutions are just the blocks that you could be putting on top of it. Predictive maintenance being one of those blocks, it looks something like what you see on your screen right now. After it has been implemented, I'm going to showcase to you one of the snapshot of a sample we've implemented in Kazakhstan. You can see starting from all the way to the left, we have campaign analytics, real-time operational analytics, we have real-time field and sentiment analytics as well. And at the end, you see the predictive maintenance and safety analytics. Now, as I mentioned, that these are just the blocks that you could be putting in. These solutions within themselves are a project of its own, and definitely they have a huge impact. But combine all of these things together, and what it gives you is something that all the CEOs or the CFOs are looking forward to actually get the information right, dashboards in order to get to the stage that they want to, which is operational efficiency, reduce downtime, and reducing the cost of operations in the longer run. What we see over here, the next one is specifically for a oil pump, where we created a digital twin as well, the animated digital twin. It works in real time. It actually showcases us if the pump is working right or not, how much throughput is getting out of there, if there's any sensor that is faulty or not. As you can see on the left, the machinery has remote access. It can be started, restarted, checked through the camera if it's working right or not. You see multiple KPIs on this dashboard where it's telling the vibration, where it's telling the temperature, or telling the wheel acceleration as well. It's also telling us if the oil that is coming through is or constrained through any reasons, and that needs to be checked as well. On the right box, see right over here, there's a predictive maintenance box, which is telling us that there is a part that needs to be changed, and if it's not changed in the right time or days that it actually mentions, there's a hazard for fire. This kind of innovation actually brings you to the next step. Now you are able to change, for example, let's just talk about the specific case or the specific warning that is coming up right here, is that if you're able to change it within the time, you are at a peace of mind. You are able to let your stakeholders know that things are under control. You are able to let your need to actually on their capabilities to figure out or be paranoid about having the solutions right in the place. You can just do it exactly in time without actually wasting the life of that specific part too. Because as you can see, it mentioned a few days before it actually goes wrong. And something that you can do is take it all the way to the end of its life and then change it. This gains you the number of days, the number of hours of usage from that specific part. Given this, I think if I am the industry leader, it looks very feasible for me to have the things done in the right way and the most efficient way as shown right on the screen. If I'm not actually doing it, there could be a few of the blockers. As I mentioned above, there could be internal resistance. There could be lack of envisioning, for which we do the briefings. There could also be a fear of huge capital costs to begin the solution, or the overhead cost to actually maintain the solutions. But this is something that we actually cover in one-to-one briefing for your specific solutions. We let you know the cost. We tell you exactly what hardware you need. We have the hardware partners as well, from which we can procure any kind of sensors that are needed. We let them have installed as well from the skillful installers, and then we move towards the full implementation. But even before that, the POC that we do has a very strict success criteria, which we're going to be discussing in a little while as well, and seeing how the solution can be great for your own industry. A few of the other use cases that we have seen that are catching up pretty fast in the world. Apart from our own customers who have implemented the solution, is one of those, the Newcrest Mining, hailing from Australia, where they experienced 4,700 minutes of downtime in just 6 months. And some from someone who actually knows what would look like and how tricky they can be and how many small cogs are involved in the industrial solution specific for mining. This is a number that should jolt anybody who's reading them. Now, the solution, the unreliable sensor data limited visibility into one flow, disrupted production, and posed great safety risk as well. What was the solution? The solution, I would summarize it for you, as I mentioned just right now, is that it was based on Azure-based IoT services and the edge AI capabilities. Now, this is just the technology part of it, but think about it in terms of the business. Once you have the solution, the system collects the real data from ruggedized sensors. The sensors obviously are equipped to work in brutal situations, but obviously they have their own life as well. They detect the failure, they predict the maintenance inside, and are shown on the flow monitoring, even in bandwidth constraints. So there is a question that we do get a lot, is that, for example, I'm working in the construction industry and we are working in places where there's no Wi-Fi available. How exactly is your solution that is heavily relying on internet going to work? Well, in those kind of situations, we use stack edge devices. The stack edge device is basically a solution done in the box. You have a GPU enabled device, which is doing all the modeling right on the edge, which means that it's being done on prem. And even if the internet is not very good, maybe you have a connection coming in like 3 days, 1 day, it's getting connected to the internet on that frequency. Whenever it does connect, it's going to take up all the data to your cloud, but it's not going to stop doing what we put it for. So if you're doing it for the predictive maintenance, all the modeling is done right on the prem. All the insights are actually shown to you right on the prem, and it actually reduces the latency as well. So when we say the real-time analytics, sometimes in order to have a little bit of leeway, people do mention that it's near real time. But if you're using the stack edge device, it's actually real time. And we're getting the insights right away on our dashboard. The second one is Furnas from Brazil, a major electricity utility, which includes over 21,000 kilometers of transmission, 15 hydroelectric plants. The company sought to enhance operational efficiency and reduce maintenance costs. Now, these were a few of the, you could say, the first ones, the paramount ones who were able to do it without seeing that there is a lot of loss going on. Obviously, they have a whole pocket made just to cater to the loss. So in their case, it was very important that they actually move to the predictive maintenance, because there are so many components involved that it's basically very hard to scale. Now, with this solution that they've put in by connecting and collecting and consolidating data from and sensors across their facilities and bringing it into a singular place and trying to make sense of it, they are able to actually scale on a much faster way, because all they got to do next is just copy and paste the solutions that they have already developed in the case of predictive maintenance. And that is one of the benefits that I always try to tell my own customers as well, that this is something that you just got to do once. Once the model is in place and it's in the relearning mode and it's in improving itself and this rate is going up, this is something that you can just pick up and paste in the other sectors of your working or the operations and get the same benefits out of it. All that needs to be done is just to tweak the model a little bit according to the specific solution that we're trying to build. The third one and the final one that I want to share, which did catch my eye, is the Fincantieri from Italy, a global leader in shipbuilding and mechanical components. It relied on reactive maintenance for its steam turbo generators, basically because these are the ones that have been created for far too long and, like way in the past, and they were not actually equipped with the IoT sensors. And the approach of reactive maintenance led failures and increased downtime, and obviously the high costs associated to bring in people on ad hoc basis to actually fix the issues. Now, in 2020, they actually partnered with Bean Tech to implement a predictive maintenance using Microsoft Azure Data Explorer. The data integration was done in real time, and some new sensors were actually installed across 170 turbo generators. The advanced analytics utilizing the ADX's capabilities helped them to bring in the metrics and perfect the potential failures as well. And something that comes along with it goes without saying, is the remote monitoring. That's a huge benefit that comes along with it. So instead of going on in the yourself, just for the inspection, all the inspection can be done across a single screen. And the team would only need to be on ground if they have to actually replace a part that has gone bad. Now, how exactly are we going to be doing it for you? The next part is that if it makes sense, and it should, to move towards the predictive maintenance, then the scoping plan would look something like this. First and foremost, the way it goes is that we understand the failure modes. We identify the common failure modes and impact on the metrics. The fourth thing that we look for is the failure modes, the frequency of failure itself, the location and the key business metrics. Now, as I mentioned, one of the challenges over there is that the industry leaders who are trying to implement this solution are expecting the IT partner like Veraqor itself to have the industrial knowledge to know the failure modes or the frequency or the location. No IT solution partner would possibly ever be able to know what the frequency is, or which specific places the issue is coming in, or what the issue is, or specifically how do you deal with the issue. This is something for which we have the workshops done. Like, they're week long. We have multiple interviews done. We pinpoint the problems that you're trying to maintain and get the business language from you, or the information that is needed in order to understand the issues that you're going through. Only after we have the complete clarity on what we're about to do, we start developing the IT solution for it. In this case, it's going to be the predictive maintenance. The second one is going to be reviewing the existing. So if there's any kind of existing predictive maintenance models that are working, may it be black boxes that are coming in shape of the machinery, in IoT installed machinery, and any kind of solution that you're already working with, we try to look into that. And since I already mentioned that it's not something rip and replace, it's going to be making things that are already existing even better, and like reduce your own cost into, if something is already available, it's not going to be, we're going to be taking it out and putting something new. If it can be improved, that's what we do. Then we start mapping to the sensors. We identify the potential sensor types for identifying the pre-failure conditions on target devices based on the discussions that we have and the problems that we actually denote in. The example could be temperature, vibrations, or the RPM. And that's where the data starts getting flowing into the system. And now the part of the analytics starts. The last to do the recommendations, like we create the recommendations for the next step based on the discovery period, where maybe we need a little bit more data to be collected because the data sample is too small, or we have an instrumentation approach where we try to put things and have a lot of simulations done on it. So we would know if the historical baggage is not enough, then we create our own data. There's a lot of data available on the internet. One of the examples is the Kaggle data set, where we could be picking up a lot of data points from and bring it in our own solution, simulated for you, and see how specifically your industry or your solution is getting impacted by it. We have actually divided our approach in two phases as well. Based on our own experience with the customers on the ground. Sometimes there are only two ways. Either you have the IoT sensors installed and you're getting all the informations from them, and the next step is just to put in the platform or the landing zone for the analytics and implement the modeling and have the predictive maintenance and create dashboards for them. Or you're missing the first part, which is you don't have the IoT sensors. So the second phase We actually incorporate the ID sensors in all the machine. We procure it. We are partnering with some of the best hardware installers across the world. It actually doesn't matter which place you're and they're certified. They're actually very skillful in their work. They try to put in the right ID sensors, and we do not do full implementation right away. As I mentioned, that we always recommend to start with a POC, so you would know what the solution would bring you in, would it be, and scaling it just becomes easier as well. In the first phase, what we do is we leverage the power of data and AI that you already have. We bring in all the data, we proactively address the equipment failures, we try to make sense of all the data that you've been accumulating for the past years. Now, this is not exactly predictive, because in order for it to be predictive, you have to have real-time data that is coming in, or a lot of data that has been accumulated in the past. What we're doing over here is the pattern recognition. So given the data that you have in the past, we try to see where the things have been breaking specific to the parts. We see anomalies, we see where the manual intervention was done over the period of time, and if there's similar pattern that is actually repeating itself. And sometimes those kind of patterns are not very visible to naked eye, even if you have lots and lots of rows and columns and data in Excel sheet, and you spend days, and then you won't be able to figure out specifically what the pattern is. But the models that we actually create recognize those patterns and let you know that they predict in a certain way, specifically when the maintenance is needed. Phase, as I mentioned, if you do not have answers already available, we do it for you. And the question does lie in like where specifically would the IoT sensors would be coming from. Mainly, it could be coming in from Honeywell or Siemens. Those are the ones that we have worked with for quite a while. And after we have the IoT sensors put in, what they provide is the continuous monitoring, obviously a constant stream of data on temperature, pressure, or vibration, other key metrics, or and the real-time alerts. Now, this is true predictive maintenance coming in, because you are able to figure out what's happening in the now, and you're combining it with the historical data that you already have, and you are using it to model it to predict what could be happening. The benefits of this solution are definitely those three, which I keep repeating, is that increased uptime, cost efficiency, and enhanced safety at the end of the day. A lot of companies, and I've been very happy to actually see that they are putting enhanced safety of their workers and their working environment above the cost efficiency and increased uptime. Sometimes they're more concerned towards that, and that's what our approach, and I believe that the approach actually aligns with Microsoft's own mission and vision as well, to empower each and every person on the planet Earth to achieve better and more. And this is exactly what the companies are aligning with as well, and how the solution could be taking you to that step. If you look at the roadmap as to how it could look like for a POC that we could do, it does not take more than 2.5 months. It could be even lesser if given that we have the workshops and we understand what your system is. But we are trying to, like not raise the expectations the time too much. This is a very optimal time that we have decided. It could be below that, above that. But anyway, first and foremost, we start with the data preparation or assessment. We sit with you, as I mentioned, that we have workshops done with you, trying to understand the business KPIs or the issues, specific issues that you're facing, and which specific sector you would want this solution to start with. After we have that, we look at all your data that is available from that specific zone. And in the it's not just going to be looking at that data and trying to see where we could be using it. We also see what the dependabilities are. So the scope could increase way more than what we think it would be. You might be thinking that there is a single file that is getting generated for the vibrations from this specific machine, but what it is the machine impacting? We got to see the data for that as well. And what is that specific machine getting impacted from? That data has to be available as well. So we create a whole data map, like a network or a data mesh, where we know the pictures, we can visualize it as well. After we have the data, we ingest it, cleanse it, obviously the ETL or there, we profile the data, we govern it to a certain level. Not all the way, because since it's POC, we only take it to the point where the data becomes viable. right after we have the data available in the lake houses, if you're using the Fabric, which we recommend quite strongly, we move towards a model development. We train the model. Now, there's a question that I get a lot from the customers that is this model built from scratch? Well, in today's age and era, there's seriously, it's very rare to actually develop a model from scratch because there are models available from Microsoft as well, which are industry tested and they have actually have a high success rate. We pick up those models and customize it for you, which means that we're going to be saving a lot of time on the development cost and the efforts as well. So we pick up the pre-trained models and make it even better. These pre-trained models have confidence rate of above 70%, 75%. But once it comes to us and we have data from your side to train it, the confidence rate can very much move in the place to, between 93 to 100% zone. And really goes to 100% because obviously we cannot predict the future completely, but it gets very to predicting how the things could be going out. Then we have the visualization on top of it. Now, this part is the most interesting for me because this is where I see the information. I love to see what we have gathered from the solution that we have put in. This is the final step where everything looks very just saw the Chevron dashboard as to what the RPM is, what the vibration is. It's telling us specific alerts and escalations as to where the predictive maintenance is supposed to be done. It's showing me which machinery is moving in the right direction or not. It's showing me which sector is getting hit or affected by the downtime or by the production losses that we are making. And this visualization box is developed very closely in integration with the KPIs that we gather in workshop with the business leaders of the industries of your company itself. We try to figure out what KPI are most of them, and it's customizable to the teeth. Plus the validation where we have PO demonstration, we do the validation with real world scenarios. So if it's needed, not have the required data or for any kind of regulation, you're not able to share your data with us for the specific POC, it's not a problem at all. We always pick up the data from the open sources and try to simulate it, the solution for you. So the demonstration is real time and it's a real solution with actual dashboards, actual models and your data or the open source data that we're working with. And it has a strict success criteria, which means that if it's not a success, obviously there's nothing on your part. And things are supposed to be done in a way that it actually satisfy your KPIs and bring the fruition of your efforts. And in the end, when it's done, we put the final refinements. Sometimes what happens is that model that already been created becomes a blueprint of full implementation. And I would say that we call it a POC, but it's a full working solution in itself, and it's highly scalable. All that got to be done to it is that we have better and more validation pipelines. We have more data that is coming in. So there's multiple integrations that are going on. The size of the lakehouse, the warehouse is going to be increasing. The model definitely, since it's a relearning model, it increases its own confidence rate after a certain period of time. The visualizations could become better. The reports and the pages could be a little bit more. The KPIs could be increasing, but that's just building on top of what we have already provided, which means given you have a POC, even if you have that skill or the in-house team built, they should be able to scale it. So we always do a very approach on that. We never try to oversell anything. We always want you to have optimal costing done, efforts done, so you have the operations on an optimal level. And that's basically our motto as well at Veracor, that in your success, our success lies. And we never want to, take out from a single project what's not supposed to be taken out of. We always try to recommend to specifically what you need and how it can be scaled to the next level as well. After we are done with all of it, I believe this is much like a summarization. What do we get out of it? Is optimize outcomes in a strategic next step. After we have done the POC, the expected outcomes would be that you will definitely be able to see the actionable and timely failure prediction for that specific zone that we have done the POC for. The cost and efficiency insights, they will be right in front of you. What you gain out of is what the capital is that would be required, how much effort would be required, and specifically what you'll be able to see, what kind of cost savings and the efficiency would be there. And it's not just some theoretical thing. All of these specific numbers are marked to the teeth, which means they're very tangible, and you will be having all of these in percentages, trying to deliver it to your stakeholders as well across the board. And the scalable architecture, as I mentioned, that once we have the POC components in place, this can be is scaled to any place or anywhere, whether it's Veracor or your own internal team. It should be it shouldn't be very difficult to as compared to starting from the scratch. The future consideration for performance improvements comes in as well, where we mentioned if you do not have the sensors, we get the sensors done. We have the advanced ML models done as well. And lastly, which is very, very important in the overall strategy or the framework of the solution, is the data governance and the compliance. And this becomes very easy as well. So as I mentioned, that predictive maintenance in itself is just a block that you put on the overall infrastructure that you have built. So data governance comes along with it. And once you have an analytical solution put in place, you could be governing anything that is coming into it or outside of it, or anything that is being boiled right inside. And for data governance, we've been using Purview a lot, and we have partnered with Prophecy too, which means that we are able to actually have master data management, data quality, data cataloging, deduplication, harmonization, all kind of stuff right efficiently right into the single platform without even changing the screen. So it's a little gift, not a little, it's a huge gift to your own internal IT team as well, not just the business stakeholders who are looking for the KPIs to be met, but across the board, the solution actually matters to improve the cultural integrity and the strategy, the data strategy or a business strategy as well in the longer run. This actually marks the completion of all our discussion, and I hope that this was something that you found interesting. We are always available and ready to actually take you to the next step. Predictive maintenance was something that we have been taking care of for a while now, and we picked this topic up quite recently because the AI is very much on the uptrend. And what better would it be to actually get this embedded right into the stakes where the production matters the most and the operations are supposed to be moving in the right direction. We are waiting and inshallah looking very much forward to work with you as well and share all the collateral that we have and have briefing sessions and POCs done for you as well. Please reach out to the information as you see on the screen, and we'll see you for the next one. Thank you. Assalamu alaikum.